All right, so now we're going to continue our word problems from exercise 12D, H12D. And so we've already derived the formulas. We're going to be going back to those formulas. Okay, so an object is projected with an initial velocity of 5, 2 from point 1.5 meters above the ground. Okay, write down the acceleration of the vector for the particle while in flight. Okay, so our very first equation that we figured out was that velocity, initial velocity, is u cosine alpha, u sine alpha. Okay, so I'm replacing. I'm gonna. Oh, sorry, we're not there yet. I'm jumping the gun. Okay, um, write down the acceleration vector for the flight. It's going to be 0 and negative 9.8. It's not accelerating left or right at all, and it's only accelerating down. Okay, question B. Find an expression for the velocity. Okay, so we just said that the velocity was the x component was u cosine alpha, and the y component is u sine alpha. Okay, right? So, and since the velocity formula is this, we can make I can make this equal to that. So I'm going to say that's equal to 5, and I'm going to make this equal to 2. Okay, so I'm going to replace this guy here with 2, and I'm going to replace u cosine alpha with 5. Okay. Okay, next part. Find the expression for displacement. Okay, so here's the displacement formula which we came up with on the earlier page. You might want to hit pause to find this formula. And so C1, I've got constant 1 and constant 2. Now we started at 0, 0. It doesn't say that, but that's... Oh, wait. No, we didn't. I lied. It started at 1.5 meters above the ground, didn't it? So since it started at 1.5 meters, its initial position is 0, 1.5, right? It wasn't moved left or right, so it started at position 0. And the height, because it was 1.5 meters above the ground, the height is going to be 1.5. So that means constant C1 is going to be 0, and constant C2 is going to be 1.5. And so that's going to give me the displacement vector of this. Okay, so this is my vector to give me position. This is my vector to give me velocity, and up here is the boring one that gives me acceleration vector. Okay, so question C now. Okay, find the time at which the particle strikes the ground at the horizontal distance it has traveled during its flight. Okay, the time at which the particle strikes the ground. So the time it strikes the ground is when y equals 0, right? So you can see I made a mistake earlier and I had to rethink it. So y is going to equal to 0 when I make this equal to 0, right? So what I can do is I can plug this into my calculator, and that's going to give me the easiest way to figure out that height, or that time. Okay, so if I plug this into my calculator, clear, negative 4.9 x squared plus 2x plus 1.5, because we started at 1.5 height, and then I'm going to need to change my window. Max, let's make that 10. The minimum doesn't matter. Let's make that 20. I don't know. So what does this graph look like? Okay, maybe I made it. Let's change the window again. Make the y max equal to 5. We don't really need that to ever be less than 0, because it's only going one direction. Okay. So, so right here we need to figure out what the value is. So, second trace, we're going to pick 2 for 0, enter, and I can't really see what I'm doing here. I'm going to change this window again. Y minimum of -1 doesn't allow me to see this very well. Let's try that. And I didn't like that to be 0. I wanted to see more what was going on. Oops, oops, oops. What am I doing? -5. That's what I meant to type in. Okay, so I want to find out when this is 0. Second trace, 0. And enter. I'm going to find the right bound. Enter, enter. And it's at 0.93 seconds. Okay, find the time at which the particle strikes the ground and the horizontal distance it has traveled. Okay, so I also need to figure out the horizontal distance traveled. So the horizontal distance traveled is 5t, right? So I'm going to plug in this time value in for t, and then that's going to tell me that I've gone 3.97 meters. Okay. Okay. A stone is thrown from the top of a vertical cliff, 50 meters high, with the initial velocity of this. Okay. So my initial velocity is equal to 4, 2, right? Okay. So write down the velocity vector for the stone at time t seconds after the stone has been thrown. Okay, so the initial velocity, as we noticed before, is u cosine alpha, u sine alpha. So I can replace, whenever I look at my earlier equations, I'm going to replace u cosine alpha with 4, and I'm going to replace u sine alpha with 2. Okay. Okay, so the velocity equation from the earlier page is u cosine alpha minus g, gravity times time, plus u sine alpha, and I'm going to replace this and this with a 4 and a 2. Okay. Hit pause anytime you need to. All right, so that's my velocity vector. Okay. Question B. Find the displacement vector for the stone, taking the point of the projection at the origin of the coordinate system. So here is the displacement vector formula from the earlier page. And just like before, I'm going to replace this with 4. And I'm going to replace this here with a 2. And everything else stays the same. And since it's starting from the origin, uh, C1 is equal to 0 and C2 is equal to 0. So we don't have to worry about a C1 or C2. Okay. So this is our displacement vector equation. Okay, question C. Find the time at which the stone hits the ground at the base of the cliff. Okay, so the stone's going to hit the ground at the base of the cliff when this is equal to 0, right? But we're starting off at 50 high, so that has to equal to below. It's going to fall 50 additional feet down. Okay, so I need to. So if I add it to the other side, this is the equation I'm going to have, and we want that to be equal to 0. So once again, I'm going to hit y equals, type in my equation, plus 50. Okay. Second trace, 0. Okay, and we want to find this place over here. Okay, left bound, right bound, and it's 3.4, as you can see. Okay, question D says, find the distance from the base of the cliff when it hits the ground. Okay, so now I know I've traveled for 3.4 seconds. So that distance that I've traveled is 4 times t. So I'm going to replace t with 3.4, and now I know the distance traveled is 13.6. Okay, let's do question 3. And then for the ones after that, I'm just going to show you the answer and let you try to figure it out. Okay, so question 3. A particle is projected from the ground at an angle of 30 degrees to the horizontal with this speed. Okay, so here is my speed. And so just like before, initial velocity is u cosine alpha and u sine alpha. So we know that our speed u is this value here, and we know that alpha is 30, right? So I can use my calculator and I can say, okay, well, 14.7 cosine 30 is going to give me 12.7, and if I do 14 sine 30, then I'm going to get 7.35, as you see here. Okay, so that is my initial velocity. Okay, question B. Find an expression for the velocity of the particle. So we know the velocity of the particle can be written like this, right? So I'm going to replace u cosine alpha with 12.7, and I'm going to replace u sine alpha with 7.35, and the rest stays the same. And that is my equation for the velocity vector. Okay. Question C says, find the time at which the particle attains the greatest height. Okay, so the greatest height happens, if I go to my earlier page, the maximum height happens at u sine alpha over g. So using that formula, u sine alpha over g, right? U sine alpha, we know, is 7.35, and gravity, we're using 9.81. So my maximum height is 0.749. Okay. Question D. Find an expression for the displacement of the particle. Okay. So the displacement of the particle, we use this expression, right? And once again, u sine alpha is 7.35, and u cosine alpha is 12.7. So we're just replacing those, substituting it out. Okay. And that is my expression for displacement of the particle. Question E. Find the greatest height by the particle reached. Okay. So the greatest height happens u squared times sine squared theta divided by 2 times gravity. Okay. And we got that on an earlier page, right? Okay. So I'm going to replace, this is the same thing as u sine alpha squared, right? So I'm going to replace that with 7.35, and then divide by 2 times 9.8, and then there's the greatest height that we get to. Okay, question F. Find the horizontal distance traveled by the particle while in flight. Okay, so the horizontal distance traveled. So first I need to figure out what did I do here? Find the horizontal distance traveled while the particle is in flight. Okay, so on equation 11, on question 11 here, the horizontal distance traveled, we used this equation. So we know that u sine alpha and cosine sine alpha gives me this, and 2 divided by gravity is going to give me 4.9. Okay. And then question G says, find the minimum speed attained, and we get this. All right, question 4. Okay, I'm done hiding the page. I'm just going to explain it through now. An object is projected at an angle of 30 degrees to the horizontal from the point at the ground level. It hits the ground again at 6 seconds. Find the initial speed of the object. Okay, so it starts at the ground and then it hits the ground. So that makes it easier. When it starts at the ground and hits at the ground, we figured out the time was equal to u times the initial speed sine alpha divided by gravity. We know the time is 6 seconds. So, and we know that we're trying to figure out the initial speed. Trying to figure that out. So I can multiply both sides by 9.8. I could divide both sides of the equation by 2 and sine 30, and then I get u is equal to this. Okay, that was an easy question. I didn't need all that paper space. Question 5. This one was a little tricky. Okay. It starts off at 1.5 feet off the ground. There's a wall that's 10 meters away, and it's shot at an angle of 45 degrees. So find the expression for the displacement of the ball over time. Okay, so initially we know it's 2 cosine alpha and sine alpha, and we know that u is 10. Right, we start off with 10, and our angle is 45 degrees. So I do 10 cosine 45 and 10 sine 45, and then we get these values for my initial velocity. Okay, our displacement formula from our earlier page is this. Since we're starting at a height of 1.5, then my C1 value is going to be 0, and my C2 value should be 1.5. Okay, so as I said before, since we're already starting at a height of 0, our C1 value is going to be 0, our C2 value, our height value, is going to be 1.5. Okay, question B. Find the height of the wall. Okay. So, so to figure out the height of the wall, well, to find out the height, we use this equation, right? So the first thing I need to do is, we know this wall is 10 meters away from where we're starting. So when we've gone 10 meters, we need to figure out how long it takes for the thing to get 10 meters. And so I'm going to use this. This right here gives me my horizontal distance. 7.071 times t gives me my horizontal distance. So 7.071 t, when that equals to 10, then I am at the base of the wall. And so I divide both sides by 7, and I get 1.414 seconds. Okay, so now I'm going to find the height when we've gone 1.41 seconds. So I'm going to replace t here with 1.41, and here also, and because I'm just using this equation here, and I'm replacing the time with 1.41, and then we figure out the height of the wall is 1.73 meters high. Okay. Question C says, find the horizontal distance traveled by the ball before it hits the ground. So we want to find the height when it hits the ground. Okay. So so the first thing we need to do is figure out how long it takes to hit the ground. So I'm using this equation here, and second trace 0, and that tells me that this, when I get here, it takes me 1.63 seconds to hit the ground. So now that I know how long it takes to hit the ground, I can plug that into my x component, and then I will find the horizontal distance traveled in order to hit the ground. Hit pause at any time that you need to check something. Okay. Last question. The particle is projected at a speed of 50 meters per second. And so I'm going to replace u with 50, right? And we have an angle of 30, so I'm going to replace alpha with 30. And so write down the initial velocity vector. So I'm going to multiply 50 times cosine 30, and I get this value. And I'm going to multiply 50 times sine 30, and I'm going to get this value, and there is my initial velocity. Question B. Find the displacement of the particle from the point of projection T after the particle is projected. Okay, so remember, it starts off 2 meters above the ground, right? So here's our displacement formula from the earlier page, but we know it should be plus, we should have here plus 2. I don't know why I didn't write that there. Okay, we should put plus 2 here. Okay, because at t equals 0, c1 is 0. There's no horizontal movement, and the vertical movement is, we start off at 2. Okay, so plus 0 and plus 2. Okay, so this is my displacement vector. Question C. Find the length of time for which the particle's height above the ground is greater than 22. So the easiest way to do this is to type in this height equation and this height equation, and that's going to give me this horizontal line and this parabola. And if I change the window, then I'll be able to see where these intersect. Okay, and this intersection here happens at 0.993, and this intersection here happens after 4.108. And so if I subtract those two, that tells me how long we're in the air. So this whole part right here is when we're above 22 meters. Okay. Question D. Find the time at which the particle hits the ground and the horizontal distance traveled during that flight. So to figure out when it hits the ground, I'm going to make the y component, the y part of my vector, I'm going to make that equal to 0. And so then I can do second trace and figure that out. The horizontal distance traveled is, if I take this, my displacement vector, we know it's 43.3 t, so I'm going to replace t with 5.18, and this is the horizontal distance traveled. Whew.